intervals for the mean in samples. So when a sample size is less than 30 and the random variable x is approximately normally distributed, it follows a t-distribution. T-distribution is similar to the normal distribution, but it has little difference. So the formula of t-distribution, the t value of t is that. So the properties of the t-distribution. Just like normal distribution, t-distribution is also bell-shaped and symmetric about the mean. And the important thing in t-distribution is the degrees of freedom. The degrees of freedom are the number of free choices left after a sample state such as x bar is calculated. The degrees of freedom is the sample size minus 1.
Yeah, very simple.
So we say n minus 1. So when you use t-distribution, we have to consider degrees of freedom. That's the most, the biggest difference from normal distribution. So just like normal distribution, the t-curve also has the area of 1 or 100%. The mean, median, and mode of the t-distribution are equal to 0. And as the degrees of freedom increases, the t-distribution approaches the normal distribution. What it means, after 30 degrees of freedom, it looks like the distribution. So as the degrees of freedom increases, it looks like more Z distribution, and if degrees of freedom are low, then it is thicker. So the critical values of T for a 95% confidence when the sample size is 5, we have to find this. And there's table. So the degrees of freedom is, the problem said the sample size is 5, so 5 minus 1 is 4. So the degrees of freedom is 4. And we have to find 95%. So with calculator we can find it. Okay, so turn on your calculator.
Turn on your calculator, please.
Okay, so second 하고 bars.
What?
You press second and the bars.
I will show you. I will show you.
Okay.
Wait.
화성이 있어? 사장님.
Wait.
클리어 옆에?
You go to second and distribution, and there's
인부티.
no, normal T. Where's? Oh yeah, this one 6. Second distribution and 6.
6.
Yeah, and you can use lower bound and upper bound degree of freedom. Then you will get the interval for the confidence interval.
Okay.
Okay. So upper is it's at 95%. So here this area is 95%. So here will be 2%. 2.5% and here 2.5%. Understand?
Yes, yes.
Uh-huh. So so here is 95% plus. Understand?
Yeah.
Okay. So 5%. So the area is, we can say
Yeah.
so in calculator
아하.
Yeah.
the lower bound is
Yeah.
the default.
Then in this case, you should use inverse t.
Yes, I was.
Yeah.
Yes.
Yeah. What?
Inverse
Okay.
t
What?
and 0.975, and degree of freedom is 4. Then you will get this number.
Yes. So the answer is 2.776 and 계산기 어떻게 없애나요?
홀리 째요.
Just yeah.
Okay, so we have the value here.
Can you
Okay, so the 95% of the area under the T distribution curve with the 4 degrees of freedom lies between T equals plus minus 2.776. Okay, then constructing a confidence interval for the mean. So the case that we use T distribution is usually when we do something with sample mean, not population. So okay, so we use T distribution when we don't know the standard deviation. This is very important.
That's good.
If we know the standard deviation, then we have to use Z distribution. But if we don't know the standard deviation, we have to use T. But if it's population, then we use no. When it's proportion, then we use Z. But this is simple mean, and we don't know standard deviation, so we use T distribution. So the margin of error. Did we learn margin of error?
Yes. No.
No.
Yes.
Yes.
Yeah.
Yeah.
Okay.
Yes.
So
My friends.
Yeah. Confidence interval consists of point estimate plus minus margin of error.
Okay.
Right?
So
Yeah.
the
Yes.
confidence interval was in population was mu plus minus margin of error.
Non-view x bar.
Okay, X bar. And we can use T distribution to find out the margin of error.
Yes.
Yeah.
And the formula of margin of error is
T. Yeah.
critical value, the standard error,
Which is
which is
s over square
S
root.
over root n,
Yeah.
and here is S.
No. That's it. Just that's it.
Okay. Sorry. Okay, SC. And this is S over root n.
Mm-hmm.
And the n is sample size and S is the standard deviation of a sample. Okay, so in this problem,
Excuse me. What is T critical?
the T value.
Okay.
Okay.
Which we found with the inverse t function.
Okay, so the problem is in a random sample of 20 customers at a local fast food restaurant, the mean waiting time to order is 95 seconds, and the standard deviation is 21 seconds. Assume that wait times are normally distributed and construct a 90% confidence interval for the mean wait time of all customers.
Mm-hmm.
Okay, so in this problem, we know the sample size is 20
Yes.
and the x bar is 95
Mhm.
and s is 21.
Mm-hmm.
So, for confidence interval, we can write 95
Mm-hmm.
plus minus oh, t
Yeah.
equal
21. Yeah.
like this.
Mm-hmm.
So we have to find the t value. So turn on your calculator again,
Okay.
and we have to find the 90%. So so second part and number 4 inverse t. Yes, so this middle area is 95% and the left and right side each 5%. So we plus
90.
90 is 95.
Yeah. What?
Okay.
5%. 5%?
Yeah.
So here is 90%
Oh, okay.
and here is 5 plus 90, so 95% here.
Oh, yeah. Okay.
Okay, so the area is 0.95
And degree of freedom is
and the degree of freedom is n minus 1, so 20 minus 1 and 19. So degrees of freedom is 19, and then paste.
then you get
Then the t value is approximately 1.73. So if you calculate that, 1.73 곱하기 21 21 divided by root 20. Then we have the value of plus minus 8.12.
mm-hmm.
So this is the confidence interval
for this scenario.
for this scenario.
Yeah. Let's check by PowerPoint. Yeah.
Okay. Good.
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 Okay.
Okay.
That's it.